All right, welcome to Unit 7. In Unit 7, we're going to do more complicated equations. Before we get to those complicated equations, we're going to review some procedures that you should have seen in 7th grade, but we're going to go over them all again. And the first one is how to combine like terms. So there's a pattern here to this warm-up. See if you can figure out what it is. So we have 3 plus 3 plus 3 plus 3. Well, that's 12, right? 4x, what's 4x mean? 4 times 3. So that's also 12. That's interesting. Both of those had the same answer, 12. Let's look at the next one. We have 2 times 3 plus 5 times 3, because x is 3. And order of operations have to multiply first. So 2 times 3 is 6, 5 times 3 is 15. Then you add them together and you get 21. Okay. In this one, you're doing 7x, which is 7 times 3. Well, that's interesting. Also 21 as the same answer as number 3. Okay. In this one, we have an x, that's 1x by the way, plus 3x plus 4x. And so we have 3 plus 3 times 3 plus 4 times 3. And again, we're going to do order of operations. So we have to do our multiplying before any adding or subtracting. And we're going to get 3 plus, and then we, right, well, it's all adding, so we can do commutative property, right? But order of operations would say do the one on the left. 3 plus 9 is 12. 12 plus 12 is 24. All right, in this one we have 8 times 3, 8x, also 24. All right, so the left side and the right side had the same answers. Why is that? Well, they had to have the same answers. They would have had the same answer. If I had x is a million, the left and right side would still have the same answers as each other. It wouldn't be 12 and 21 and 24 anymore, but it'd be different numbers. But 1 and 2 would have the same answers, 3 and 4 would have the same answers, 5 and 6 would have the same answers for any value of x up here, for any value of x. And why is that? Well, it turns out that's 1x. And 1x plus 1x plus 1x plus 1x equals 4x's for any value of x. So number 1 had 4x's in it. Number 2 had 4x's. Now, in number 3, how many x's are there? Don't say 2, right? There are 2 x's right there. That's 5 x's. And so that adds up to 7 x's. X's are just like apples. If you have 2 apples plus 5 apples, you don't have 7, you have 7 apples. Same thing with x. You have 2 x's plus 5 x's, you have 7x. So no matter what x is, that's what this equation is saying. No matter what x is, those two are the same, and these two had to have the same answer. Number 5, there's 1x plus, right? We don't write this coefficient of 1. We've talked about this, but there's 1x there plus 3x plus 4x. That's 8x's, right? And so those two had to have the same answer. Let's make sure we understand that. I now tell you x is a million, right? Both of these would be 4 times a million. Both of these would be 4 million, okay? Numbers 3 and 4, both would be 7 million, right? You could do all the math out, and both of these would be 8 million, right? Because they're going to have the same value no matter what x is, right? So that's what we're doing today, you know. And so combining, by the way, all right, so what does that word mean? Combine in English means maybe to mix together, but in math it means add or subtract. There is no multiplying or dividing today. Now, you might multiply as a shortcut, but you are adding or subtracting when you're asked to combine. All right, so there are many kinds of terms, so we have to understand. A term is defined by the variables in it. So if it has an x in it, it's an x term. If it's a y, it's a y term. It have both x and y, that's different than either of the other two. An xy term is different than an x term and different than a y term. And numbers count as terms. Right? They're called numerical terms. Now, I made a list of 4, right? But there's terms with p in it and q and whatever. And p and q combined, there is an infinite amount of different terms. Okay, now, so this is an expression, 2x minus 9. How many terms are there? There are 2 terms. What keeps the terms apart are is the subtraction or the addition. So this is an expression with two terms. Okay, and what did I ask in the question? How many different kinds of terms? And there's two different kinds. There's two terms there, and they're also different, right? One's an X term and one's a number. So they're two different terms. Next one. There are 1, 2, 3 terms, and they're all different. So we have 3 different terms, right? A Y, an X, and a number. 3 different terms. Okay, one more time. Okay. All right, so here we have 3 terms, but 2 are the same, right? So we have 2 different terms and 2 that are the same, right? But I asked the question, how many different kinds? 2 different kinds of terms. Right? And it turns out when they have the exact same letters with the exact same exponent, we'll go over that some other day. But when you have the exact same letters, you can add them together. But when they don't have the exact same letters, you can't. All right? They have to have the exact same letters or no letters at all to be added or subtracted. But when they have the exact same letters, you can add them. And that's called combining. All right, so we have a 5x plus a 3x plus a 7x, right? Since it's all plus, you can add it in any order, so you might want to add those 2 first, all right? And so it doesn't matter, say we're simplifying that. We're not going to know what x equals. And this is really the basis of algebraic thinking. People who don't understand the value of algebra, what they go out in the real world, anytime they're missing some information, they give up. Oh, I don't know the length of this or what this is. I can't do anything. That's so not true. Okay? X is missing information. Now, we have 5 times that missing information plus 3 times that missing information plus 7 times that missing information. And if you don't understand algebra, you just think, wow, there's a lot of things I don't know. But what we do know is that once we learn the missing information, the answer will be 15 times that missing information. We've made this whole problem simpler. It's called simplifying for a reason. Math, we name things well, all right? It's well named. We made that simpler. All right, so that's 12x. Take away 11x. So hopefully that's 1x, but you never write that in an answer. You just write x. So no matter what x is, 1,000,000 or 3.4, if you have 12 of them, you take away 11 of them, you'll have 1 of them. Okay? It doesn't just work for x, right? It works for y. So that is 14y. There's 1 y there, right? So remember, we don't write those coefficients when they're 1s or negative 1s. All right? So we're going to do this with integers as well. So that's negative 1xy plus 7xy. Add those together and you get positive 6xy, right? Because negative 1 plus 7 is 6. All right, now, they have to be the same type to be combined. If they're not the same type, you leave them alone. So in this, if you're asked to simplify this, it's 6x plus 7. Stop, all right? And let's understand why that is. If I tell you you have 2 apples and 4 apples and $7, right? If you have 2 apples and 4 apples and $7, you have 6 apples and $7. You don't have 13 anything, right? You don't have 13 apples, you don't have $13, you don't have $13 apples. You have 6 of something that's like each other and something else. Okay, so it's 6x plus 7. All right, 6y plus 8x minus 3x. So we have 6y plus, right? So the only thing that can be combined here, normally, right, you would do order of operations, but you can't add those because they're not like terms, right? So you do 8x minus 3x, which is 5x. Okay, so say you had 6 bananas and 8 apples and 3 apples, but we lost 3 apples, right? After we had 6 bananas and 8 bananas, but then took away 3 of, did I say that right? 6 bananas, 8 apples, and then we took away 3 of the apples. What would we have left? 6 bananas and 5 apples. Okay, again, so there's negative 1x plus 3x. All right, so this, you're adding this because of the plus in front. It's always about the symbol in front of what we're talking about. So it's negative x plus 3x, which is 2x. This plus right there is telling us that that's positive 7y. It goes with that. So we add this one because of that y. So 7y plus 1y is 8y. So whenever it's positive, you'll get a plus here. If it comes out negative, you'll get a minus. And we'll have notes on that in a second. Okay. So to find a perimeter, what do? Right? You add up all the sides. So we're going to have 4x plus 3 plus 4x plus 3 plus 5x. 4x plus 4x plus 5x is 13x. 3 plus 3 is 6 plus 6. And so it's positive 6. And so, yeah, we don't know some missing information, but we know the length around this whole triangle will be 13 times that missing information plus 6. All right. So let's look at this very odd price chart. It says the pen is 3x and the pencil is x and the eraser is 50 cents. What this is trying to tell you is this, whatever the pencil ends up costing, the pen is 3 times the cost of the pencil. Okay? So now we have to find the total cost, which means you have to add things up. All right? So we have 2 pens, right? So we have 3x plus 3x. Whoops. And let me erase that mistake there. 3x plus 3x. And yes, you could do that in your head. It does add up to 6x. Okay. And then 3 pencils. Let's do it in different colors. So 3 pencils, they're each x. All right. And so 3 pencils, they're also 3. They're 3x, right? Because they're x each and there's 3 of them. And then we have 4 erasers. All right. And the 4 erasers are 4 times 50 cents, right? Well, 4 times 5 is, right, it's 20, but we move the decimal point, that's $2. So when we add these all up, you get 9x plus $2, or 9x plus 2. So the total cost of 2 pens, 3 pencils, and 4 erasers will be 9 times the cost of the pencil, right? That's the cost of the pencil, right? 9 times the cost of the pencil plus 2, right? Once we know the cost of the pencil, we'll know the value of anything else, because the pen will be 3 times that, 3x. All right, now this is the only tricky thing about this. I said this already, so let's see this already. So right, we subtract this 3x because of that, because the subtraction goes with the symbol goes with what's right after it. So we're subtracting that 3x, or it could be a negative 3x, but the negative goes with the 3x. So right there is a positive sign in front here we don't write, right? But 5x minus 3x is 2x. Okay, and then that plus tells us that's a positive 4. That's what it's telling us. 4 plus 5 is positive 9, and so the answer is 2x plus 9. Positives will turn into plus, negatives will turn into minus, really without you even doing anything. Okay, so let's look for, right, you have to find the like terms here. So, right, we have 8 minus 2. 8 minus 2, right, because that's positive 6, so we just write 6. Then we find some more like terms. We have positive 9x minus 7x. That's positive 2x. And we can write 6 plus 2x. Now, in algebra class and later in the year, you're going to want to turn that around. We write the x first and the number second. But not 9, 6, sorry. All right, but these are equal, and it's fine to leave it that way today. All right, 7x minus 7x, right, is 0x plus 4. Well, what's 0 times x? Well, 0 times a million is 0, 0 times 1 is 0, 0 times everything is 0. So this equals 4. So look how much simpler we made that. We don't even care what x is now, and that can actually happen more often than not. Well, more often than you think. In this problem, it turns out since we had the same amount of x's and then we took them all away, it didn't really matter that we didn't know this information because the answer is 4 no matter what. 5x minus 7x. Okay, so we finally have a negative, right? That's negative 2x. Okay, because it's 5x minus 7x. Right? The plus sign that's right there goes with 6y. 6y minus 8y, negative 2y. And so notice, read that out loud. What would you say? Negative 2x minus 2y. Right? There's nothing about those symbols in size, when you don't have anything in front here, then it must be a negative, right? When you have something in front, it must be a minus. Okay, you'll have teachers even say these wrong, but this is negative 2x minus 2y. Because when you add those together, notice you get negative 2y, and it turned into minus 2y without you doing anything, right? Okay, so we're going to replace the question with a number to make it true. Well, let's see what it says. It says 9x plus blank y plus 5y equals that. Well, the 9x made this 9x, so we really, it's right, something times y plus 5y equaled 4y. Blank plus 5 equals 4. What is the only thing that can go in that blank? Well, hopefully you realize the question mark must be negative 1, right? Because 5 is bigger than 4, so it must be a negative number. And so it's negative 1 plus 5 equals 4. All right, so let's practice all this. All right, the like terms are 7x and 3x. We could add those together, right? 8y and 8 are not like terms. You can only add or subtract terms with the exact same letters. Circle the coefficients, right? Negative 3 and 5 are coefficients. They are numbers multiplying variables. The letters are called variables. 1 is a constant, which also starts with C, but it is not a coefficient, okay? Because it doesn't have a variable that it's multiplying. All right, we're going to simplify. 6x minus x is 5x. 9 plus 13 is positive 22, so it becomes 5x plus 22. 17xy minus 1xy is 16xy. 3 minus 3 is 0, so we're not going to write plus 0. We're just going to write 16 times xy. Right, and that's not the multiplication symbol, that's x. So it's 16 times x times y. 5x minus 6x, negative 1x. Now, in an answer, you don't want to write it that way, but we'll get to that. Negative 7y plus 8y is positive 1y, right? Now, perfectly good to write that in the middle of a problem, but in the answer, you're going to write negative x, or the opposite of x, plus y, right? Because we don't write those ones as when they're coefficients. Okay, so we're doing 1 pen, which is 4 times the cost of the pencil, 4x, plus 3 pencils, x plus x plus x, plus 5 erasers. And so I'm going to just do 5 times 50 cents. 4x, 5x, 6x, 7x, 5 times 5 is 25. This is $2.50, right? Also known as 2.5. And so once we know the cost of the pencil, it'll be 7 times the cost of the pencil, plus $2.50, 5 times 50 cents. All right, good luck with the homework.